We would like to find all values of -1 to the power square root of 2, and we would like to indicate the principal value of this expression. So a complex number, z, raised to a complex power z to the c, is defined as e to the c times the logarithm of z. So that's the definition. And it comes from the exponential function and the logarithm being inverses of each other, and the property that says that we can put this c as a power here, and then the exponential and log canceling out, you would get z to the c. So there's our definition, and this logarithm is the multi-valued logarithm, multi-valued, and so we will get many values for this exponential expression. So let's see. The value of c in our example is the square root of 2, and the value of z is -1. So -1 to the power square root of 2 is equal to e to the power square root of 2 times the log of -1. Now the log of -1 is equal to, this is the complex logarithm, this is the natural log of the modulus of -1 plus I times the argument of -1, and this is infinitely many angles here. And when we talk about the principal value of the exponential expression, then we will use the principal value of the argument. So this is equal to the log of 1, the modulus of -1 is 1, plus I times one argument of -1 is pi, -1 being on the negative real axis. It has polar angle of pi, and then there's infinitely many, plus 2k pi. Now the natural logarithm of 1 is 0, so this is just I times pi plus 2k pi, and therefore -1 to the square root of 2 is e to the power square root of 2 times I times pi plus 2k pi. Then the principal value, let's see, the principal argument of the number -1, the principal argument is pi. So the principal value of -1 to the power square root of 2, we will just use pi for the argument. That's the principal argument. So it would be e to the power square root of 2 pi I. That's the principal value.